These sessions, as always, has a generative AI theme. And in the previous session, which was in November, we presented a very interesting and innovative demo, which was on an application of AI agent in engineering. And that demo was about a simulation agent, which is a practical application where you can use AI agent to perform parametric studies for you. And it intelligently executes a bunch of tools. In that case, it was executing a finite element solver, which was Abacus. And it adjusts the next step to basically just do your sensitivity study or parametric analysis until reaching an objective. But starting from this session, we are going to begin building a production-ready AI agent. So it's not going to be a demo anymore. It's going to be an agent that's production-ready. You can implement that at your organization, and you can basically use it. So it's designed for enterprise deployment. And our first step in here is to develop an advanced multi-modal RAG with a direct integration to SharePoint. It's deployed in Azure, so it's pretty secure. And we think that that would be a great entry point for any organization. And once we have it, we can package it as a tool for an AI agent. So the way that we progress, we're going to build our multimodal RAG. And then in the following sessions, we are going to package it as a tool for the AI agent, which is going to be the final goal. And in building this app, the focus is on security, transparency, and delivering the minimum viable features. We're not going to have a app with so many features. So we're going to stick to best practices that ensures those objectives that I just mentioned. And as always, a brief introduction to Arcurve, which hosts these monthly webinars. Founded in 2006, Arcurve is a full-service technology, advisory, and software development company. It guides organizations across different industries on their data journey, helping them leverage technology to enable data-driven decision-making capabilities. So let's start by a quick overview of our bios. My name is Farhad Davaripur, and I'm a lead data scientist in the advanced analytics group of Arcurve. I've been with Arcurve for less than 3 years. By education, I have a doctorate in civil engineering from Memorial University. And I have been in industry for about 7 years in different fields, including building and implementing data solutions, primarily using AI and ML, and building final simulation models using FEA, and also performing pipe stress analysis. I've worked at Technip FMC, at Northern Crescent, AutoML, and now I'm working at Arcurve. I'm pretty passionate about bridging the gap between engineering and tech. I think that I'm in a place that I know I have a decent knowledge about both worlds, and I really like to find ways to demo and show some of the capabilities that tech can provide for engineers in order to streamline their task, and that's some of the reason behind some of the demos that we show, not all of them. And in my personal time, I enjoy playing ping pong, mountain climbing, traveling, and making and eating sushi. So I pass it on to you, Mike.
Thanks. I too am an engineer, come out of an engineering background, spent quite a number of years in the mining industry, working and helping develop three-dimensional mine modeling, blast simulation things. Back then we used to call it statistics. Now it's more broadly known as machine learning. I've worked in a number of different industries and domains, including environmental, financial, architectural engineering, construction, of course, mining, and more recently energy. And co-founded a company called Menome Technologies in 2016, where we developed a platform called the Data Link that continuously integrated data together into a knowledge graph that was then used to generate insight. That company was acquired by Arcurve in 2020, and since then, I spent a lot of my time advising strategic advice on AI applications into enterprise and also focus on the engineering domain as well, and doing a lot of public speaking on the subject because it's really important, given the chaos this week with DeepSeek, to help organizations really understand what the impacts of this technology are and how it can be effectively leveraged into enterprise, which is the intent of these seminars. When I'm not doing that stuff, yeah, a lot of mountain biking and play music in my daughter's band, which is quite fun. And then some improv stuff as well, which also helps with the speaking thing. And that's me.
Awesome. Cool. So as for the agenda of this presentation, we will start by discussing the business opportunities of leveraging retrieval augmented generation, RAG, which is integrated directly with SharePoint. That's one of the key pieces in here. So SharePoint, Azure are the key pieces in this presentation. And also the whole RAG has been abstracted out using Llama index. We'll talk about that further. So we have basically started. We have selected RAG because, again, as I said, it's the most accessible entry point for any enterprise to begin adopting to LLM technology. After that, we will briefly review different types of RAG systems, which is followed by a more technical discussion on cloud architecture, source code, and implementation of the multi-modal RAG that we're gonna do a demo, and we also want to share the source code so you can also implement that on your organization. And finally, we will discuss the missing components, which will be the focus of the February webinar. Okay, now I hand it over to you, Mike, to discuss the business case for implementing RAG in an organization's in-house knowledge repository.
Thanks. Yeah, so it's a really interesting domain, and it's been one that I've been fascinated in, this idea of trying to find and leverage knowledge that's stranded in these large file stores that all organizations possess. This has been a thing that's been a challenge for quite a while. And while we've now got this whole new world of AI and models and whatnot to go after this challenge with, it's not as simple as just dropping, an AI model into a spot where you then stick a bunch of PDFs into it and then magic ensues. There's a bit more to it than just that. And it does get into the background around understanding what files are, how we kind of got to the place that files have become a standard method and means of storing them, the structures that are used to manage and store files currently. So I wanted to explore a little bit before we dive into the how we solve the problem with a bit of why we have the problem in the first place. And for that, we need to go back in time to 1972. Next slide. So there's an even larger backstory to this, which I explore in some other lectures that I do on the history of the subject of knowledge in technology. But there was a particular point in time in 1972 where a number of different thoughts and thinking processes came together in Xerox PARC. And I imagine some of you have heard of this, the lab that was set up by Alan Kay, who you see here in 1972 to start pursuing the creation of a vision that he had, that he articulated in a paper called A Personal Computer for Children of All Ages. And he published this in 1972, in fact. In that, he described a device called the Dynabook, which you see drawn out here, which looks remarkably like an iPad. And there's, of course, a reason for that. Mr. K eventually ended up working at Apple, where then all the vision for this ended up. I got to see him speak at UPSLA when he received the Turing Award for his work, which was pretty amazing. The thought behind, and he talked about the Dynabook and sort of the parts of it that he had envisioned and why things had kind of ended up where they are, falling very far short of his original vision. The idea behind this device is that it was supposed to be a dynamic knowledge collaboration platform in which the objects that were the knowledge elements could be created and shared and were not bound by any specific application or anchor. The knowledge objects themselves would be manipulated through a simple language called Smalltalk, and then collaborated across different platforms between people in a very seamless manner. If we go to the next slide, though, of course, in 1972, they didn't exactly have the technology to pull this off. So what ended up happening is the limited machine intelligence that was present at the time that this concept started to be put into practice meant that some pretty major compromises had to be made to make the stuff work. And if you go to the next slide, what we see is what Kay called the Alto, or the interim Dynabook. Didn't quite measure up to the portability aspect. As you can see, this thing was the size of a fridge, the Alto machine, but it was still pretty incredible for the time that it was constructed. And it did some really remarkable things in terms of having a fully functional graphical user interface. They created the Ethernet, they created laser printers, all of that. Basically, everything that we see and experience in current computing paradigm was available on this machine, albeit in a more limited fashion. But to pull the thing off, though, to get the what you see is what you get paradigm working, so that you could have a document that followed the standard human format of writing things on paper, they had to create a construct called a file. And to store the file, which is a file that's basically was envisioned as a container that could hold both pictures and text and other artifacts in sequence, so that it could then be presented on the screen in the same way that it would appear when it was printed out. To store these things, of course, same problem emerged. The network was available, Ethernet, but in a very, very rudimentary fashion. So what that meant is they had to come up with a very simple but very limited way of storing files. And if you go to the next slide, they acknowledged this fact at the time that this was created. And the really cool thing is I actually was able to track down the original research and the user's manual associated with this, which is still floating around out there on the internet. And you can see that they literally describe the fact that the Alto stores files on disks of all the material you're working on, text and pictures, as well as most of the programs which provide the services. The named unit of storage is called a file. Each different document you handle will be stored in its own file. Better facilities, the facilities for identifying files are not ideal, but you'll get used to them after a while, and better facilities are the subject of current research. And then they go on to describe how naming conventions, which we all know and no doubt love, not really, were the means in which you were supposed to go about doing this. They also acknowledge in the same document the fact that this paradigm, they recognize the fact that it would not scale very well. Now the research, if we go to the next slide, as many of you may know, that of course that research never happened, because a guy named Steve Jobs showed up at the Xerox lab and went, wow, this is pretty amazing stuff. I'm going to take this and commercialize it, which he did successfully somewhat with the Macintosh, which then led to Windows, which then led to what we see now. Problem is that because of the limits of technology available at the time, again, the Mac had a very, very limited amount of memory. So they basically had to copy, to get the graphical user interface even functioning at that time, meant that they still had to bring across the very limited concept of the way the knowledge that these machines were storing the file and the folders associated with it was also brought across. And the research that was supposed to happen around making better ways of interacting, searching, finding the knowledge that these files stored never actually happened. So if we go to the next slide, as we know, the Alto in 1972 is basically the same user experience that we have currently. We still have icons, we still have applications, we still have files. That's the primary way we interact with systems today. And again, it all comes back to the fact that the limited machine intelligence that was present in 1972 resulted in design decisions that we are still stuck with now. And it's this idea of having to use metaphors to translate human commands into machine understandable actions. And that's resulted in some incredible complexity as the machines and the stuff is spread to now we have clouds and everything else, because people are actually forced to work through these limited metaphors so that the machines understand what we're trying to ask them to do. And if you go to the next slide, there's a couple of problems with this whole paradigm as it was brought across. The first thing is that files are atrociously terrible databases. And the idea that, well, at the time where it was revolutionary, this idea that you'd be able to have pictures and text and diagrams and other things stored in this container called a file that was then indexed at the top, essentially at the top level, meant that people went nuts with this. So many of you no doubt had seen the atrocious landscape of what we now know and despise called PDFs. these have been very, very resistant to any kind of indexing. To be able to get knowledge out of a PDF is very, very hard. And it's literally because of the fact that the container is a mishmash of a bunch of some of its instructions for formatting, some of its commands for the way the layouts are done, the way that pictures and other artifacts are embedded in PDF files is very complex and quite opaque. So it's become a real problem. Compounding that, if we go to the next slide here, is the fact that the systems, the original file store, the network drives, those are still around with their file folders and naming conventions of nested content, all the multiple levels. People have different ways of describing the same types of storing the same types of artifacts. So a person has to know a great deal about how to store and where to store something so that they can find it and get it back again. And that's the problem has been compounded by the fact that there's Teams, there's Dropbox, there's files stuck in Outlook, Google Drive, and so on. Files get spread all over the place. So trying to index all of this and trying to make it so that somebody can actually discover where the specific file or artifact that they want to work with, bit of knowledge is quite a challenging problem. And if we go to the next slide, this is the opportunity that AI starts to afford for us, is AI is making it easier for us to finally find that knowledge because the machine intelligence is finally starting to be up to the job of interpreting the human content that lives inside of these containers called files. So AI makes it easy to find the knowledge that's typically buried inside of the Raiders of the Lost Ark level file stores, like SharePoint, enabling then machines to work more like people instead of people having to work like the machines. If we go to the next slide, and the reason for this is because the models, based on the way they're trained and based on the way they function, you can give the thing a page of information and it can actually look at that and interpret the things that are on that page. And the machines can now understand the fact that this artifact that you see down that diagram is in fact a diagram. It can read the text on that diagram. It can read the text inside of the document, and it can also translate that into other forms, back into useful data again. Same thing with pictures. And Farhad's going to illustrate this today, where these multimodal models are capable of not only just working with the text, they can also pull back information about describing the pictures and what's in them, and they can make that information also discoverable. The thing, though, is to note with all this is you can't just throw a PDF at one of these things and expect it to suddenly work. There's a bunch of things you have to do in behind the scenes to make the information that's in these PDF files amenable to the processes that are then make the content discoverable and accessible by people. And really quickly, not going into all the details of the challenges, but on the next slide, we need to make sure, because there's some other governance things that come into play with this as well. What's the best way to process the files? The files are typically scattered all over the place. You get files in SharePoint, you can have files on many different types of network drives and whatnot. Those things all have to be somehow pulled together and then broken down into this retrieval augmented generation pattern. So you're actually taking the content of the files and breaking it into little chunks, which then brings up another interesting challenge around security and governance. We won't go into that in low level detail in this forum today, but the basic security aspect, Farhad will show you some of that in terms of how you start to, effectively have logins and things that check to make sure the user is able to chat with the agent and so on. But there's another deeper problem around the fact that if you've got a financial document that's in a secured folder and it's got confidential information, some boilerplate, some confidential, how do you make sure that that chunk of stuff that's coming out of that's confidential still is not being exposed by the LLM when somebody asks it a question? The other thing too is, as we all saw with this whole DeepSeek thing, is how do you ensure that the enterprise, the investments you're making in these models and whatnot and setting them up to be chattable is durable? And it all comes back to the fact that you have to have a well thought out strategy and an architecture that ensures the reliable results that factors in some of these other considerations beyond just, hey, I can talk to my PDF. Wow, that's exciting. If you go to the next slide, and that boils down to having and applying typical good software development practices and proper data governance to this domain. Map out the data value stream, understand where your files and documents are, understand how you're going to go after those things, and then use that to inform the design of the system itself. To reference the DeepSeek thing specifically on the next slide, the other really important thing is to make sure that you're abstracting out the model piece from the framework that's doing all this processing and whatnot, so that when the new models come out, you can just drop them in and get access to those capabilities without having to change everything else around it. Because this is, particularly with what's happened, and there's another presentation we do on the subject of acceleration and why models are accelerating the way they are. This is going to keep happening, and it's probably going to happen even faster with the political situation in the US now removing barriers and regulatory constraints from development, and of course with the arms race, as it were, that's going to ensue because of things like DeepSeek emerging. If we go to the next slide, this gets into the notion to kind of manage all of this stuff. Really what we're talking about is setting up for this particular use case a file processing framework in which you have part of the system is acquiring the files, they're decomposing them down into the appropriate form that's necessary for retrieval augmented generation to work properly. There's a bunch of agents that need to introspect the nature of the content that's on the page so that the prompt condition that's needed to understand and extract information, describe pictures correctly to get the text out in a clean format so you're not getting distortions or, as they're more commonly known, hallucinations and whatnot. And then there's a curation part. You need to make sure that the information that's being put into this thing is accurate and acts as a reliable foundation, so that your retrieval augmented generation process and the interaction between the user is providing reliable results and is also capable of providing the source of where the information is coming from back to the user, which Farhad is also going to illustrate. And with that being said, I will turn it over to Farhad.
Oh, that was great. Awesome. Thank you, Mike. I was looking forward for your part because we didn't get a chance to go through everything together in the prep sessions. That was great. It was a fantastic history and setting the stage for this part. With that introduction, starting from here, we are going to review some of the key concepts of RAG applications. We're not going to spend too much time on understanding different pieces, but we want to just know about different RAG applications or different RAG systems before getting us started on the demo and on the architecture and the source code for this particular project. By the way, the source code will be shared on the chat by one of my colleagues, and you can have access to that and you can implement that at your company. So any RAG solution requires the steps outlined in this slide. The first one is indexing, which effectively means that whenever you have a document, let's say if it's a PDF document, you need to parse the text, if it's just the text or extract text from the images. And once you have all the information, you have all the extracted text, you need to chunk that into smaller sections. Let's say that you have 1 page worth of text, and let's say you are using a very basic and rudimentary chunking strategy, because the chunking strategy would be extremely important in the indexing pipeline. And if you want to use like a fixed chunking method, then you probably want to split your text into 2 pieces. And once you have done that, we need to have a mathematical representation of each one of those pieces. In other words, we need to create an embedding, or we need to vectorize that chunking piece. For these, we are using some embedding models, like the ones that's out there by OpenAI. That's called ADA, or it also has like a couple more embedding models, large and small, based on like the dimensionality of that vector that it generates, but you can leverage that. And once we're done with the indexing pipeline, which is probably the most important piece in terms of the accuracy that you're going to get out of the RAG system. Then it comes down to, then we have the storage. We need to store that, extract the text, the raw text, with the metadata that you might have extracted, and also the vectors associated with each one of those text chunks. For that, we often either use the vector database or the graph database, so also known as, vector store. And then once we have that, that's a retrieval step. So the retrieval step is where we, based on the query that's coming from the user, we create an embedding from the user query, and we already have the vectors or embeddings for each one of those text chunks. And we use some of these strategies like using cosine similarity or Euclidean distance, or just simple dot product of the vectors, in order to find the closest vector from the document to your query vector. And once you have that, then you have your most relevant chunk of text. And then in the last step, you need to feed those relevant text chunks to the large language model, which is the synthesis step, in order to come up with a coherent answer. And of course, you also need to return the sources, etc., which are also pretty important for transparency. But these are the bare minimum of what a RAG application or a RAG system requires to have. So if I go to the next step, we're going to talk a little bit also, like there's another slide that we want to talk more about these different RAG systems before just getting into the multimodal applications that we're going to demo. And that is to talk about like different kinds of RAG system in terms of advancement and sophistication. There are so many open source packages out there, like LangChain, LlamaIndex. Llama Index is my favorite because that's specifically good for RAG application. LangChain to me is a little bit more general package. So they are used to abstract out a lot of these steps that we talked about in the previous slide, while creating, it's also important to note that while creating these RAG pipelines, specifically the basic or vanilla RAG pipelines, is quite straightforward, especially with these packages. Developing a production-ready RAG application, it's pretty challenging and requires expertise. And by this session, and probably one more or maybe two more, the main goal is that we do a knowledge transfer, and at the same time, we have a source code that has the minimum viable features so that you can implement it at your organization. So now let's go through like a few key terms that we hear typically in the context of RAG. We hear about advanced RAG, we hear about the multimodal RAG or the agentic RAG. What are they? So the advanced RAG includes the components that ensure accuracy. So we wanna definitely implement evaluation metrics for different parts of the pipeline, because without that we have no control and we have no observability. It can't be transparent. And also we want to make sure that it's scalable and it can handle high traffic. Also, we need to be able to retrieve sources when based on which the final answer has been generated. So we want the system to be accountable, and how we ensure that? By making sure that the sources are easily traceable. It can trace it back. We can trace back the answer to where it's coming from. And the best way for that, that we also want to just show, is that we have a screenshot of where the information is coming from. Let's say that the information is coming from a certain document. If the RAG system can take a screenshot of that particular part of the document and return that to us, and also have a link so that we can also go to that document on our knowledge repo, let's say SharePoint, that would be great. To me, that's probably one of the best solutions, or it creates a lot of transparency. And finally, multimodality. That's quite important, which is basically the main scope of this session. It is because a lot of the documents that we have, they have at least two modality, which is text and image. So I also missed like the inference time. So the inference time is also obviously important. We don't want to wait 10 minutes for an answer to be returned. The system should be pretty fast. Otherwise, like we probably might as well spend time to figure it out ourselves, just going through different documents. So that was about the advanced RAG. In terms of the multimodal RAG, not significantly more, except it extends these capabilities. It has different modalities. As I said, at least text and image. That's quite important. And like with having these multimodal models like GPT-4o that Mike mentioned, it has become significantly easier to extract both images and text, especially some of these packages like Llama Index that I'm a big fan of. They abstract out some of these steps, and you just need to introduce your multimodal model, in this case GPT-4o, and they manage parsing text and also parsing the images for you. And what they do is that they have a raw text and they have the extracted text from the image, or a text that describes an image in a markdown format. And finally, we have agentic RAG. It's a little bit different than the AI agent that we typically develop, because the AI agent that we typically develop is that we have an AI agent and it has access to the bunch of tools and it can execute them autonomously. In here, that's the same concept, but this concept has been integrated within RAG. And the way that it works is that instead of having a static retrieval, for instance, you will transition to a dynamic and autonomous system that can plan, refine, and adapt its retrieval strategy. And it can do that based on the query and based on the evaluation results. Let's say that you have asked the question and it retrieves some text chunks from the document, and it uses like one particular pipeline to do that, and then it assesses the evaluation metrics, for instance, accuracy or etc. And then it realizes that it's not accurate enough or it doesn't hit the objective of the user. And then it autonomously make a decision in order to go with another pipeline to achieve a better accuracy. So this way you have an intelligent system over there that can make the best decision in order to give you the highest accuracy or whatever objective that you're looking for. Of course, whenever you add agentic system or you have any agent within your system, it becomes less deterministic, but the behavior is going to be more intelligent. And yeah, I mean, that's why for these AI agents, whenever they make a decision or wherever they are incorporated in any system, we always want to make sure to see all the steps, intermediate steps, and that's what we have been showing in all the previous demos. Because like the reasoning steps, we can observe that and we can see what's going on, and based on that, we can make sure that it's exactly what we're looking for. Yeah, with that, I'm not going to get deeper into the RAG system. I wanted just to set the stage, give a little bit of intro, and now I'm gonna I'm gonna just start talking about this particular application that we are going to demo in a few minutes. Just excuse me for a second. In this application, the front end and the back end has been isolated, and each one of them has been developed separately. So as for the front end, it's been developed with React and Node.js, and it's been deployed on the Azure resources. So the source code has been Dockerized and packaged and published in ACR, the Azure Container Registry. And in order to spin up the image, we are using Azure App Services, which is great for the start. I mean, if you need more flexibility, you can use AKS, Azure Kubernetes Services. But for the purpose of these sessions, this is great. It abstracts out a lot of the steps about networking, and it make the process a little bit more streamlined. And of course, we have Azure Entra, or it was formerly called Azure Active Directory, in order to get the token and just like take care of the authentication. This is the front end that you will see. I didn't want to spend too much time to make it fancy. This is the bare minimum of what you need for your production ready app. Um, so these are like a few elements that you see in here. The first element is that you need to sign into the app in order to be able to use the app. And before that, you're not able to submit any query. So in this case, because my token has been expired, you see that the submit button is not active. So I just need to refresh the token, and what it does, it will go and grab the token from the Azure Entra app registration, and then I'm able to submit the query. There are two endpoints on the backend side that we will talk about in the next slide. One endpoint is to submit the query, and that's probably easier. And the other endpoint is indexing the new documents. So once the token has been extracted and indexing and query submission has been authorized, so the user can either like send the query, or it can also index a new document. And you will see that you will see an example of that, and you will see how easy it is to index a new document or submit the query. Before getting into the demo, we are going to talk about the backend as well. Pretty much like what we did for the front end. The backend has been developed using Python and Fast API. We have a couple of endpoints that we want to talk about here. So these are the main endpoints. Indexing a new document, like the majority of the components or complexity is happening here. And then we have the query endpoint. By indexing endpoint, what we effectively do, we index the document, and then we will store that in Azure AI Search. And during the query, we effectively go to the Azure AI Search, find the index for that particular document that we are looking for based on the query, and then retrieve that index, and we use that index in order to answer to the user question. So that's the pipeline at the high level. And if we want to get a little bit deeper, the steps involved in the indexing endpoint would be, first, because we are directly working with SharePoint, which to me is the key point in this architecture, because there are a lot of cases that the company has like documents, and they don't want to like move their documents. For instance, their documents is in SharePoint. In most cases, the documents are in SharePoint, and they want as is to build a RAG application against their knowledge repo. So what this app does is that it allows you to keep your documents where they are, and you can just simply like integrate that with the system. And even whenever you have a new document, you can also add those as well. So this is for both the like existing document or adding a new document. We need to run this endpoint. And the first step is to download the documents from SharePoint. Again, we are using the Azure Entra ID in order to get the token. And once we have the token, it will go and call Llama Parser. Llama Parser is one of the PDF parsing or document parsing. Probably one of the most powerful PDF parsing, and it's not open sourced. You need the API key. You need to get the API key from Llama Cloud, but it allows you, I believe, to parse 1,000 pages for free per day. And what it gives you is that it allows you to use, and that's probably like enough for most use cases. And you have a couple of like items in here. So you can add custom metadata. For instance, I've added pages or the image URL for every page that's been parsed. And you can also add the parsing instructor, because that's pretty important in the multimodal parsing. You want to make sure that you provide instruction so that the LLM follows if you have a specific document or you can also provide a general instruction that can be applied across the board. So what's happening after is that it extracts each one of those images as a screenshot, and each one of those images are going to be uploaded to the Azure Blob Storage. You will also see that in action. And you also add a SAS token at the end of each image URL so that there is security, so that not everybody can have access to those images that are stored in Azure Blob Storage. The next step is that those markdown extraction from the document, along with the metadata fields that you have defined in here, along with these image URLs, they are going to be encapsulated as a node. So this node includes the text, images, metadata, everything. And then we again use llama index, which abstract out creating the index. It will create the index, which means that it will create the embeddings, and it will streamline the whole process for us. The embeddings or vectorization is being done on the text, and then you have all the other metadata, and then you can store that in the Azure AI search, which is your, vector store in here. So Azure AI search has a free tier that you can use, and it allows you to create index up to 3 indexes. And yeah, that's what we have been using in here. So a lot of these services that I've leveraged, you can use the free tier, and you can just deploy that in your company for free, just to have a sense of how the system works. And once you are comfortable, you can probably transition to like a basic tier. Still, it's like pretty cheap, but you can probably gradually make your application to accept more and more traffic. There's another step that I haven't talked about in this part, and that step is that for each document, we are going to create a summary of that document, and that summary is going to be a dictionary, which is stored also in Azure Blob Storage. And what we are doing in here, we are using this dictionary, which includes each document with a summary associated with the document. And we also, when the user sent a query in the other endpoint, we send both the query and the dictionary to the large language model, to the LLM, and the LLM decides this query corresponds to which document, and then uses that document in order to retrieve the relevant index from the Azure AI search. So of course, this approach won't work if you have like thousands of documents. What you need is that you need to add a RAG layer in here, like a basic RAG. And what this RAG does, it will embed the query, it will embed each one of these summaries, and it will only retrieve 3 of the documents with their summary and pass it down to the LLM. So this is another piece that we're going to add in the next session. So in the next slide, once we are done with the demo, we'll also talk about what are the next steps. And so once we have the document and then we get the index that already has been stored in Azure AI Search, then the next step is we have the query and we embed the query, and we also have the index. So again, we are using llama index in here, so you don't need to manually do any of that. So you just write down your query, and the llama index take care of embedding and everything. So by the way, like embedding, large language model, everything is being done within Azure, and we are using Azure OpenAI, or it's also like there is also Azure AI Search, which effectively using Azure OpenAI. So everything is contained within Azure. We are not like making an API call outside Azure. So that's why this is also another layer of security for your company and for your documents. So once, based on the query, we retrieve some of the pages for that particular document, there's another important step is that re-ranking, because in here we might retrieve 5-10 documents, 5 or 10 pages, but we don't want that 10 pages to be fed into LLM because that's going to be expensive. So the more token you feed into the LLM, it's going to be more costly because the cost is per token. So we use a re-ranking component in here. What it does is that based on the query and based on the retrieved text chunks in here, the pages, it's going to re-rank that and only filter it out to, let's say, 3. So in this case, we're using 3. And then the 3 pages are going to be passed on to the multimodal query engine. And as you can see, we have multimodality not only at the beginning and also in here. So you can also pass down both the text and the images to the multimodal query engine, and you can understand both of them. And then it generates a coherent answer based on the user query aligned with the sources of the text node, image node, and the document URL on the SharePoint. So you can just directly click on it and it will take you right to where the document is on the SharePoint. So yeah, I think that's as much as I wanted to talk about the architecture. Now I would like to go and talk about this part, the demo, which is the most interesting part. And for the demo, as you have already seen, we have a super simple front end, which was my intention. So you first need to sign in, and like once you sign in, the token expire every now and then. So you need to like refresh your token. And once it does that, it will go to the Azure like Entra ID and it will grab the new token. This is your token, which is significantly more complex than this. I just show you like a few of the like first few boards, and once you have that, it allows you to start either like triggering the indexing endpoint or submitting the query endpoint. For the purpose of this demo, what I've done, this is the SharePoint that we're working with. This is called RAG test. I've added like a couple of documents. I've already indexed them. And I'm going to ask a question about like this document specifically. There is a question that I already checked. It's coming from a specific image, and that's hard to get. And that's the benchmarking question I typically use. The question is, what percentage of executives, for example, disagree with scaling AI and ML? And when I ask this question, you will also see it will start generating the response. This is the elapsed time. And so before getting into the answer, you will see this is the token that's been generated and it's been passed down to the backend. So this is the log that's coming from the backend, which is on a separate Azure App Services. And these are the steps that's happening. It first authenticates the token that's been passed down to the backend, and it will start the environment. It will go through all the indexes that it has from the Azure AI search. And then it selects this particular index because of the query that you have asked us about AI and ML. It will decide that, okay, so this would be the document that I'm going to ask to retrieve information from. And once it does that, it will retrieve the information. It retrieved 5 nodes. And out of those 5 nodes, it re-rank it and filter it down to 3 nodes, the most relevant nodes. And this is quite important because if you don't have the re-ranking component, what will happen is that you will end up with a bunch of relevant nodes that first expensive, and second, typically the first node wouldn't be the one that's most relevant because these cosine similarity, Euclidean distance, these approaches do not guarantee that like the closest vector is going to be the answer you're looking for, unless if you are extremely specific on your query. And also, I mean, you have done a great job on the chunking strategy, which we will talk about in the next session. And yeah, it will have those image URLs as well, which are the URL to get you to download the image directly from Azure Blob Storage. And once you have all that, it will just like send you back the response. So this is a response that's been generated. The response is 8%, and it tells you that it's on page 12, and it tells you that you can get that from figure 5, AI priorities for executives. And this data is presented as a part of survey result. It provides you a bunch of more information, and the whole thing has happened in like about 7 seconds. So these are pretty much everything that we're looking for an advanced system. And in addition to that, we also want it to be transparent. We want to know where information is coming from. Let's say that this is a situation that you have hundreds of documents and you want to just with a click, you get to the document where the information is coming from. So this is a document where the information is coming from. And this is like a data bricks. I mean, each one of these documents, they're publicly available. And if I go to page 12, where the information is coming from, this is the information that we were looking for. 8% of the executives disagree on this image, and 78% agree. And another important piece that I mentioned is that in addition to being able to go through the documents, we don't want every time that we ask a question, we go and check out the document. It really takes a while if we are interacting with RAG. We want to see where the information is coming from instantly, but as a screenshot. This is also what this app is giving us. It gives us the screenshot where the information is coming from. And as you can see, the information is here, disagree 8% and a priority for executives. So another important piece that we have been talking about is that the main problem with LLMs is that it's a black box. It generates information, but we don't know where the information is coming. I mean, where the information is coming from is training data. But we want to make sure that our RAG application, we never use that training data. It always relies on the information that's coming from the document. So let me ask a question. The question would be what React Agent stands for. And I know this is a kind of word that hasn't been used in any of those two documents. That's why I'm asking. And I'm expecting the RAG does exactly what it did. So the provided context doesn't include any mention or explanation of React Agent. Of course, it knows what React Agent is, but it doesn't use its training data to answer that. It took 5 seconds. It went through some pages and it found nothing. This is exactly what we were looking for. And what we want to do now, we want to add a new document like what you typically do on your SharePoint. You just dump a bunch of documents. And we want to see what's going to happen when we want to index this new document. So I'm going to start indexing this new document. So the indexing is in progress, and you hopefully will also be able to see what's happening on the back end. So you see that similarly, the token has been passed down. Either start looking at like the token, validate that, and then this new document that has been sent, it starts indexing that. Indexing means going through all those steps and create an index and publish that in the Azure AI search, and also upload all the images to the Azure Blob storage. So this happens, this probably takes about a minute. And while it's doing, so hopefully it will also show us some logs. There is a little bit of lag when we do the live stream on the log, but this has been pretty good so far. So this has been the lag. Typically it's like in real time. So what it did was it created an image from each one of these pages from the webinar, 15 pages, and uploaded all of them into the Azure Blob storage, and it said like successful, and 15 out of 15 were successful. Total images, there were 0 failed, and 100% it created an embedding for each one of those pages. And then it says like, I also talk about the other like reports that we already have. So now with this new document that's been indexed, let me ask this question one more time and see if it's able to answer to that question this time. So now that I'm asking about what's React Agent, this time it's able to find the answer because it has access to that information. And it says the React stands for reasoning and acting. This is reasoning. What's the information? This is acting, executing tools. So this is the information that that's in that document. And again, so we can click on it. It tells us which document it has used. And for your information, we are using PowerPoint in here. So as I said, you can use any kinds of document, any kind of data type. I mean, for here, we are only using text and image, but this is pretty impressive. And it also tells you where the information is coming from. So the React agent stands for reasoning and acting, and this was the first slide that was retrieved. And yeah, probably I can try with another one. What are the key components of a React agent? And so another fascinating thing about it is that it's extremely fast. You see that, I mean, typically it's probably take you significantly more to figure that information out yourself, going through all the documents. But not only it gives you all the answer, but it gives you like a fantastic coherent answer that you can just check out and get information. So it says like the memory, instruction, actions, and loop. These are the main basically components. They are coming from this image, and that's exactly what I was looking for. So that was pretty much my demo. I can talk significantly more about this stuff, but we are running out of time. I also want to quickly talk about the next step. In the next step, as I have mentioned a few times, we want to talk about more advanced chunking strategies. In this case, we are using like a per page chunking, but there are like a few more advanced way, like semantic chunking, I mean, recursive chunking using Markdown. Evaluation is the main piece for any production-ready app. So this probably goes under the advanced chunking. We need CI/CD for this one. We need the infrastructure as code. It doesn't have it. So the way that you can deploy your whole system is just by following the README on the source code that's been shared with you. And we are gonna package that as a tool for the AI agent, which is this step. And finally, at some point, we also want to build a system that that also leverages some of these open source large language model like DeepSeek R1. And that's pretty much it. We have a bunch of reference for you to get more information about the RAG. And since we have only 2 minutes, I'm going to stop at this point and see if there's any question.